This is Jeremy Clark of jeremybytes.com, and we're going to continue our discussion of test-driven development. Today, we'll see how TDD can help us with debugging our code, and we'll also see how we can test for exceptions inside of our unit tests. TDD uses a red-green refactor cycle. This is really useful when we're building our code, but it's also useful when we're debugging our code. If we come across an error or an unexpected result, the first thing we can do is write a failing test for the state that we actually want to have happen. Then we can write our code and we'll know exactly when we fix that bug because our test will start to pass. So in debugging our code, we still use the red-green refactor cycle. Now last time we took a look at Conway's Game of Life. This is a cellular automata simulation, and it has 4 simple rules, and these rules determine whether any individual cell lives on to the next generation. And it's all based on the number of neighbors. So if there's too few neighbors, it will die of loneliness. If it has exactly the right amount of neighbors, it will stay alive to the next generation. If there's too many neighbors, it will die from overcrowding. And if there's exactly 3 live neighbors, then a dead cell can become a live cell due to reproduction. And here's the code that we ended up with that implements those rules. And we created this method by using TDD. So we started out with our test scenarios. And we have good test coverage at this point. We have 2 parameters, the current state and the number of live neighbors. So we have tested that if we pass in a live cell, what happens if the number of neighbors is anywhere between 0 and 8? We've also done the same thing with a dead cell, testing the number of live neighbors between 0 and 8. And this gives us good coverage of all of our scenarios. Or at least we think it does. Because after I hand this code off to my QA person, they actually come across another scenario. What happens if we pass in a current state of 2? Now wait a minute, a current state of 2?
2? Well, I can't figure out just 2.
Well, it turns out in .NET that an enum is simply an integer. That means even though we have specific values that we have, such as cell state alive and cell state dead, we can pass in any valid integer as long as we cast it to this enum type first. And the compiler won't stop us, and the runtime won't stop us. And this is why I like to have really good QA people on my team. As a developer, when I'm writing code, I'm trying to make the code work. My testers and QA people, they're trying to break my code in any way possible. So we're approaching the code from 2 different angles, and that way we can make sure that we get all of our scenarios covered and our users don't find these bugs for us. So let's head on over to Visual Studio and see what we can do to fix this. So here we are in Visual Studio, and here's how we left our code. Now, as we talked about, we do have 18 different unit tests that we're covering, and because we're parameterizing the tests, we actually cover them in a set of 6 different methods. Before I do anything else, I want to verify the behavior that my QA person told me about. So for that, I'm just going to write a simple method that I can debug into in order to find out what's going on at the moment. So for this, let's go ahead and say public void current state, since that's the parameter that we're testing. And then our test case will be when 2. And then I don't know exactly what I want to have happen at this point. Let's just see what's going on. So I need my 2 parameters for my method. So for current state, what I'm going to do is just take the number 2 and cast it as a cell state. And this is valid code. So even though we don't have a specific enum value for 2, we can still cast the number 2 to the cell state enum type. And then we'll also have the number of live neighbors. And in this case, we'll just use 0. Now I just want to see what the result is. So I can actually steal this code from a previous test. And what this will do is it will run our getNewState method, pass in our current state of 2 and number of live neighbors 0, and then it will tell us what the result is. So what I'm going to do is set a breakpoint, and then we'll just debug into this test. So we'll just right click on it and say debug tests. And so we hit the breakpoint right here. So I'm just going to hit this step over button and inspect the value of new state. Now we see that new state is 2. So it's actually the same value that we passed in unchanged. And if we look at our code, that makes perfect sense. We have a switch statement on the current state, and if we don't hit either alive or dead, it just drops all the way through, and we return the same value that came in. So we verified the behavior that we have. Now we have to think about the behavior that we want. Well, 2 should be really considered an invalid parameter. So what I'd like to do is throw an argument exception if we have this argument out of range. So my expected result is actually that this will throw an argument exception. So how do we test for exceptions that happen inside of our tests? There's actually several approaches to this. MS Test has kind of a limited approach, and that's by using an attribute on the test method. Now, NUnit 2.6.4, which is the one that we're using, does support a similar methodology, but it's not recommended. In fact, it's been deprecated, and in NUnit 3, this attribute is no longer supported. But I want to show you how to use this attribute because, again, it is common in some other unit testing frameworks, and we'll see exactly what the limitations are when we do this. So in this case, we have an expected exception attribute, and then we pass in the type of exception that we're expecting. So I can say type of, and in this case, we'll say argument, out of range exception. Now you'll notice that I'm not getting any code completion on this, and that's because I actually need to bring in the using statement for system, which actually holds our exception types in it. So if we bring in using system, now we see our argument out of range exception is valid in our code. So let's go ahead and rebuild and run our test at this point to see what happens. Now we do have a failing test, and this really shouldn't be much of a surprise. And when we look at the message, we'll see argument out of range exception was expected. So this is the bug that we want to fix. So before going in and writing any code, the first thing I did was write a failing unit test so that I could test the behavior that I want to have. Now we can flip over to our code and write the code that will make this test pass. And to start out with, I'm just going to create a simple guard clause. So for this, I'll just say if enum.isDefined, and then we say type of cell state, and then the value current state. So this will give us a true-false value to let us know whether current state exists in the enum that we have. So if the value is alive or dead, it will return true. Now if someone passes in a 2, this will actually return false. So in our guard clause, let's go ahead and invert this. So if this is false, then I want a particular piece of code to run. And that will simply be throwing that argument exception. So we'll throw a new argument out of range exception. And then I'll want to pass in the parameter name so we know which parameter caused this exception. And so for this, I'm going to use the name of expression. So we'll say name of current state. Now I could simply pass in a quoted string for current state, but by using name of, this makes it a bit more resilient. I know I typed it correctly because otherwise this wouldn't compile. And if I happen to refactor this at some point in the future, this will get updated as well. So with this in place, let's go ahead and build and rerun our test to see what happens. And now we see we have a passing test. But when I look at this code and start to think about guard clauses, well, shouldn't I be checking the range on live neighbors as well? Our valid values are really from 0 to 8, and anything else should be invalid. So let's go ahead and write some tests for that, and we'll look at some other ways that we can test for exceptions. So let's go ahead and create a new test, and we'll start out with the same expected exception attribute that we used above. This will help us see what the shortcomings really are when we're testing for this. So for our test, we'll say public void live neighbors more than 8 throws argument exception. And then we'll go ahead and start by copying and pasting the code from above and then just changing some of these values. So we'll set our current state to a valid value. Let's say cellState.alive. And then for number of live neighbors, we'll go ahead and put in 9, which is more than we expect. And if we build and rerun our test at this point, we see we will get a failing test. And the message is what we saw before, expected an argument out of range exception. So let's go ahead and add just enough code to get this to pass. So I'll add another guard clause. So we'll say if live neighbors is greater than 8, throw a new argument out of range exception. And this will be name of live neighbors. And now when we rebuild and rerun our tests, we'll see that that test now comes up green. So we do have a valid test that's checking to see if our cell state is out of range and to see if our number of live neighbors is out of range. But if we go back to our tests, this is where we can start to see the limitations of using an attribute for this. We have two tests, and they're both expecting argument out of range exceptions, but they're expecting argument out of range exceptions for different parameters. So how do I know that the right argument out of range exception was thrown? By using the attribute, I can't tell. What I really need to do is get access to that exception so that I can look inside at its properties. If I can look inside the argument out of range exception, I can look at the parameter property and make sure that it has the right value. Now I'm going to start by doing this manually. I want to show how we can do this to show that we don't have to rely on a unit testing framework. We can actually build this code ourselves. And the way that we can do this is just wrap our code inside a try-catch block. So I'm going to highlight the code that I want to check for the exception. And I'll wrap this in a try-catch block by using the keyboard shortcut Control-K, Control-S for surround with. I'll type in try, which is our code snippet for a try-catch block. And then when I hit enter, it goes ahead and stubs that out for me. So inside of our catch, we'll actually check for that argument out of range exception that we're looking for. Now inside this catch block, I'm just going to say assert pass. And what that means is if I get to this block of code, that means my test is successful, and we'll consider this a passing test. Now I do need to put in a failing state somewhere, and I can actually do that right underneath this line of code where I expect to get the exception. So we can just say assert fail, and we'll just give this a message that says no exception thrown. And this is the most basic way that we can look for an exception in our test. Now this will behave very similar to the code that we have with our attribute. It will check to see whether an argument out of range exception was thrown. If it is, it passes, otherwise it will fail. So if we go ahead and rebuild and rerun our tests, we'll see that this test is in a passing state, so we can actually see that we do have similar functionality to what we had before. But what I really want to do is verify that this argument out of range exception was thrown on the live neighbors parameter. So for this, I'm just going to create another variable that we can use here, and we'll call it param name, and we'll set it to live neighbors. And then down inside my catch block, I can check the properties of our exception. So I'll say if ex.paramName, which is a property on an argument exception, and we'll say if it's not equal to the one that we're expecting, then we'll do an assert fail. So we'll say, you know what? This is the wrong parameter, so I want you to fail this test. Now, if this happens, I do want to pass in a message to the user. I won't make you watch me type it, so I'll be back in just a second. So here's the message that we want to pass. Wrong parameter, expected, live neighbors, which we have as our value for param name, and then the actual is ex.paramName, so it will show us what the value is from the exception. Now to make sure this line actually works, let's go ahead and change this to current state, which is our other parameter, which we don't expect. So let's go ahead and rebuild and rerun our tests. And this should come up failing. And if we look at our message, we do see the message wrong parameter, expected current state, actual live neighbors. So this tells us that this code path is actually working. So let's go ahead and change this back to live neighbors, which is what we want. We'll rebuild and rerun our tests, and we'll see that everything comes up green. So by using this method, we can actually get the exception itself inside of our test so we can start inspecting elements. Now, NUnit does have some features that makes this easier so we don't have to write this much code. And we'll look at that in our next test, because I do have one more out-of-range exception that I want to look at. We're testing to see what happens if our live neighbors is greater than 8, but what if it's less than 0? So let's just go ahead and create one more test here. So we will say public void live neighbors less than 0 throws argument exception. And for this, I'll go ahead and grab the 3 parameters that we had above because we'll want to work with these. And then we'll change our number of live neighbors to -1 so that we have something less than 0. Now, NUnit has a number of assertion helpers, and one of those methods that it has is Assert.Throws. And in this case, we can assert that a particular line of code will throw a particular type of exception. So let's just take a look at the parameters that we have here. And as we can see, there's a number of overloads, And this is actually the one that I want to use. So the first parameter is the expected exception type. And then the second parameter is actually the code that we want to test. This is the code that we're expecting will throw an exception. So for our expected exception, we'll say type of argument out of range exception. And then we'll see the second parameter is a test delegate. So we need to pass in a delegate here. I'm just going to use a lambda expression. This doesn't take any parameters, so I'll use an empty set of parentheses to indicate there's no parameters. Then we'll use the goes to operator, and then we'll put in the line of code that we want to run. In this case, it's life_rules.getNewState, and then we'll pass in our current state and our number of live neighbors. Now you'll notice we're not checking the result that's coming back from getNewState, and that's because we don't really need it here. We're checking to make sure this line of code throws an exception. So with this code in place, if we build and run our tests at this point, we'll have a similar behavior to what we had when we were using the attribute. This code will check to see whether an argument out of range exception is thrown, but we're still not looking at any specifics on that. And at this point in time, our test does fail because the argument out of range exception is not thrown. So let's go ahead and alter our code to get this to pass. So we'll say if live neighbors is less than 0 or live neighbors is greater than 8, then we'll go ahead and throw that argument out of range exception. And when we rebuild and rerun our tests, we'll see that that test does now pass. But again, at this point, our test is only telling us that an argument out of range exception was thrown, but not necessarily that this is the one that we're looking for. Well, it turns out the throws method does return the actual exception. So we can say var ex equals assert.throws, and then we can start checking some things on this. So I want to check the parameter name like I did above. So we can say if ex.paramName not equal to our local variable param name, then we can do an assert.fail like we did before. Now you'll notice that paramName is not happy with me at this point, and that's because we have to cast this to an argument exception. That's a property that's specifically on argument exceptions. Now in this case, I'm just going to go ahead and rebuild and rerun our tests, and we'll see that it works. And we'll go ahead and change our live neighbors to current state, which is the other parameter. And if we rebuild and rerun our tests at this point, we see we will hit that fail block. So let's go ahead and just put this back and rebuild to make sure that all of our tests pass. Now NUnit actually gives us some additional features, so we don't have to test for the parameter name outside of this throws method. And this is where things get kind of interesting. Let's go ahead and take a look at the other overloads that we had on this method. So we used this overload where the first parameter is the expected type of the exception, and that's pretty simple. But you'll notice the other overloads include this iResolve constraint, and this is an expression that we can create in order to test for very specific things on the exceptions we're looking for. So let's go ahead and do this instead. Now, I'm not going to show you all of the details. You'll want to look at the NUnit documentation, but I just kind of want to show you what's available to us. So I can use is, which is actually coming from the NUnit framework, and we'll say type of argument out of range exception. So we're saying this is the type of exception that we're expecting. And then we can start adding other conditions. So I can say .and .property, and then the property name that we're looking for is actually param name. And then we can say .equal to our local param name variable that we have. Now this is a bit hard to read at this point, so let's go ahead and just split this up into separate lines, and we'll see that this actually is kind of cool. So we've just created a conditional that's very easy to read. So we start out with is type of argument out of range exception. So if it's the right kind of exception, then we'll get past that conditional. And then we have additional conditions. So we say and property name, param name, equals param name, which is our live neighbors that we have here. So we can take all of this and put it into this Assert.Throws and let NUnit handle it for us. And when we do that, we don't need to capture the return value because we're not looking at it directly. Now, if we rebuild and rerun our tests, we'll see that we do have a passing test. And then again, just to double check this, we'll go ahead and change our live neighbors to current state, rebuild and rerun our tests, and we'll see we should get a failure here. And then we can see the message that we got from NUnit. So expected was an argument out of range exception and property name equal to current state, but was live neighbors. So we do still get a very easy to read message when something goes wrong. Let's go ahead and put that back to live neighbors, rebuild and rerun our tests, and we'll see that everything does come up green. So we've seen 3 different ways that we can look for exceptions inside of our unit tests. We can use an attribute for expected exception. This will tell us whether a particular exception was thrown, but it really doesn't give us much information beyond that, so it is very limited. And again, this attribute has been deprecated and it's no longer available in NUnit 3.0, but a similar attribute is available in MS Test and other unit testing frameworks. Now we can test for them manually, and we can see we can do this by just setting up a try-catch block, putting in an assert fail in our code to make sure that if it gets past the line of code where we expect the exception, our test does fail. And then inside of our catch block, we do have access to the exception itself, so we can check specific properties or values to make sure that this is what we wanted. And then finally, we saw that NUnit specifically has an Assert.Throws method that makes it really easy to check for exceptions. And it also has a very fluent conditional API so that we can put together additional conditions so we don't have to check them ourselves separately. So that brings us to the end of seeing how debugging and TDD still go hand in hand. When we have a bug pop up in our code, the first thing we should do is write a failing test for it. Then we can write just enough code to get that test to pass, and we don't have to worry about it in the future. And if for some reason it doesn't pass, we can use that test to help us step into the code and figure out exactly what's going on. We also saw that there's several ways to check for exceptions inside of our unit tests. Flexibility and ease of use are really important. If we have a test framework such as MS Test with limited support for checking for exceptions, we can still do it manually. And if we're using a unit testing framework such as NUnit that has full support for checking exceptions, we can use a very fluent interface. It's always good to know what the options are so that we can pick the right ones for the right situation. In future videos, we'll keep exploring TDD, looking at some real-world code. So far, our code has basically been programming exercises, but we'll look at an actual application and see how we can TDD into something a little bit more complex. Until then, be sure to visit www.jeremybytes.com for more information, and we'll see you next time.